Thank you. Hi, everyone. I'm here to show you a competition we're having at Certora during this DSS. So what we're having today and tomorrow and the day after that is a competition to build a smart Solidity contract that matches our work in Certora, but in reverse. So usually what we do at Certora, we write CVL properties and CVL specification based on the code and design we get for our customers. It's hard to understand if it's easy or hard to start learning CVL. So we thought we save you the scary work of writing CVL and just do the other way around. And just you develop the smart contract, the Solidity that everyone knows, and we bring the CVL for you. So we wrote the CVL for a smart contract that is a multi-sig, and you write the Solidity. You just need a Solidity contract that matches the spec, the CVL that we wrote. The spec is very easy to understand. It has properties of this contract. We have a solution, of course, don't worry. And you need to run the prover, and don't write any CVL. You don't need to write. You can write if you want. It's very nice, but you don't need to. So break nothing, as we like to say. The task itself, you get a repository. You get the link in a few minutes. It has a README. Please read the README. We worked hard on the README. It should have answers for all of your questions. And if there is something that is missing, there is a link there to lead you to a channel that has everything. So don't worry. You get a few files. multi-sig.spec, which has the rules that describe the flow of the contract of the system. We have an invariants.spec, which is another CVL file that has a lot of invariants of the system. For example, we have an array of validators. You will see in a few minutes. We want to verify that they are always unique, this array of validators. So one of the invariants is that all of the validators in any given 2 points are not the same, always. We have a sanity spec, which what it does is checks that you really implemented anything. And what I mean is that if you start with the empty implementation that you get from us, a lot of rules, a lot of properties will just pass. You can run it by yourself and see. And the sanity spec checks that you really implemented the features. Because otherwise, if you revert always, then there is no case in which the property broke, because nothing happens anytime. Nothing happens ever. So it just doesn't break anything, and it's not interesting. So that sanity spec is there to make sure that you're really doing something. If you want, you can just ignore it and see that you can implement something very stupid and it works. So we check it. We have the state.sol. Inside we have the storage variables, so you can have what you need to use during the implementation. For example, the validators array that I told about, and we have also something regarding transactions and more stuff there. So look there. We have the run.conf that is just don't need to change anything in it. That is the hard work we did for you, so everything is packaged and just run Certora run and run.conf. And we have the empty contract for the multi-sig, which has only the external functions that should exist for you to implement, the API. And except from that, like you can do whatever you want. You can write whatever Solidity code that you want. You can do whatever, just don't touch the CVL, because we will run it against our version of the spec, which is the one you get at the start, so don't change it. So we recommend you to write a list of properties that is derived from the CVL. Like, for example, I said the validators array should be unique. More properties, of course, there will be more properties. But you don't need, like, if you don't want to, it's not a necessity. Like, you can do whatever you want, but we recommend it. Also, if you want, you can write a short description about what the system should do. It really helps to understand what should happen, and then you can start writing your code. It's like a real development process in really short amount of time. Like in 2 days, you need to develop a system that's secure. The way we know it's secure is because of the CVL, and the way that we know it works is because of the CVL. So we should have everything, and it should show you that if we write a good spec, even before implementing, it should be very easy and very fast to just implement. And you don't need to, like, you should test also your code, but if you write proper rules, you don't even need to test it because it's already tested with the CVL. Then, of course, write the contract in Solidity and run the prover and see if you're right or not. So notes. Please read the README. I can't emphasize it enough. Everything is in the README. So the code needs to compile and have comments so we can understand what you did. No bugs, of course. If we missed something or some property you think we missed, please send to us, but I think it should be fine. If something is not checked, then it's fair game. You can do whatever you want. I know that people here like to find vulnerabilities, so if you want to cheat, you can try to cheat. No hacking for other people, but everything that the prover says is OK, it's OK. So you can try whatever you want. I think we wrote a good spec, but you can challenge us and see if not. Of course, make the code as efficient as you can, because it will be important to us. But first of all, compile, then pass all of the rules, and only then efficiency. So first security, then efficiency. So we have rules and invariants, as I said. Your solution shouldn't take more than 15 minutes. Our solution is faster than that, but it shouldn't take more than 15 minutes. And of course, again, don't change the spec file, of course. If you want, you can add more invariants to the spec file, like if you need them, because depending on your solution or your approach, you might need more. And you can add them and use them. That's OK. You can always expand our definition of the system or understanding of the system, or maybe we thought that we don't need this invariant or extra invariants, but eventually it turned out that we need maybe a more efficient version of the code that we can prove is correct. We still need those invariants to prove them. So if someone wants, feel free to add whatever you want, as long as it's invariant and you prove them. But we have a solution without additional invariants, so we have everything for you. You don't need to write CVL. If you want, you are invited to write CVL. It's similar to Solidity. OK, so this is the repo, if anyone wants to scan the QR. That's also the link. Give you some time. This QR should be everything you need, because the other QRs should be contained inside of this. So if I think everyone scanned, about another minute. OK. So this is for the support Telegram channel. If something is not contained in the README, the link for this channel is also in the README, so don't worry. And I just remembered that I didn't say about the, wait. Yeah, wait about, yeah. OK, all of the rules about the rewards and about everything is inside of the README, of course. As I said, everything is in the README. So good luck, everyone. Yes. Yes. So the reward is inside of the README, but I will say it so you will read the README. So the first 3 groups or individuals that submit a verified spec that is unique. So don't copy. Like if you submit a couple of times, we will just take the first one. So they win $1,000. And we have also a bonus for 3 rules that we have, that we chosen, like it's in the README also. The most efficient implementation of of the code that will solve those specific properties fast, they will get $500, the fastest ones. So of course, in that bonus, of course, we also need to solve the other properties. Otherwise, it's just, I'm not giving you the single rule to pass, and then you can revert, and that's it. So of course, we need to pass all of the rules. And if you're fastest in that specific rule, you get the bonus. You don't need to be the total winner to get the bonus. So good luck, everyone. And if for any other reason or for questions or for anything, if you want to reach me, and this is my Telegram, if you want. And that's it. Good luck, everyone. And submission until the 9th evening. Okay. Good luck.